So now we will discuss about the Ohm's law. This is one of the common laws which you might have studied in your class 2. It states that any conductor, if you take any conductor, let us suppose this is a conductor or any material, as long as the temperature is maintained constant, if you apply potential across it, then a current will flow through this conductor. If you increase this V, automatically I will be increasing. If you decrease this V, automatically I will be decreasing. And the amount of current which is flowing in this conductor will be equal to the potential which you are applying across the conductor. This is what said by the famous scientist Simon Ohm. His full name is George Simon Ohm. He was a German mathematician. He stated this law first in 1827. So at constant temperature, the current through a conductor is directly proportional to the potential drop across it. Or in other words, I'll take a conductor. If there is a current which is flowing in this one, so the potential drop which is created across this one is proportional to the current flowing through the conductor. Okay. So don't get confused whether I is proportional to V or V is proportional to I. I'll give you a simple example. Now let us suppose there is a conductor. Whatever the current which is flowing in this one, this I is proportional to the V source. How much the voltage which you are applying, that will be guiding your current through this circuit. Now the same current is flowing across these elements, right? Is flowing through these elements, and while it is flowing, it will create voltage flow, right? So I is governed by the V source, and these individual voltage drops are governed by currents. So in either of the cases, if I take these terms as common, I is proportional to V or V is proportional to I. Okay. So if I consider V is proportional to I, then the equality constant, I am stating it as R. And this R is called as resistance. Okay. And this resistance R, we have discussed this one in the last class. It is a property of an element by virtue of which it opposes the flow of current. And this resistance varies with the nature of the material. So normally R is for a conductor. Normally, let us suppose if I take a conductor, so the length of the conductor, this is the area of cross section of the conductor, and this is the material. So this is called as the resistivity. So resistivity. So resistance depends upon the nature of the material. For a copper wire, this will be very low. For a wood type of material, it will be in terms of 10 to the power of 6. So resistivity is the nature of material, and L is the length of the wire, A is the area of cross section. This formula holds good for a wire type of material. If you go for a different configuration, if you take a square or a cuboid type of thing, then this formula may not be working. So normally for a wire type of material, R is equal to rho L by A. And V is equal to R into I. This relation holds good as long as the temperature is constant. Try to remember, if the temperature is varying, then this relation may not be V is proportional to I. It may not hold good. This R resistance, it is measured in terms of ohms, and this particular V is proportional to I, what we call it as an Ohm's law. It has its own limitations. It is applicable to only few networks, but not to all networks. As mentioned here, cannot be applied to networks containing unilateral elements and non-linear elements. So, strictly speaking, it is applicable only to linear and also bilateral networks. Okay. And coming to the next one, we will have a quick look about limitations of Ohm's law. As already mentioned, Ohm's law is not applicable for non-linear networks. So, there are a number of circuit elements which do not obey Ohm's law. It fails under the following conditions. So, see the first one. If the VI characteristic is not linear, you take diode, transistors, thyristors, all the electronic elements. VI characteristic is not linear. In this case, Ohm's law will not be applicable. The relationship between V and I depends on the sign of V for same absolute value of V, which means that if it is unilateral element, then it is not applicable. The relation between V and I is not unique. In that case also it is not applicable. So we can say that Ohm's law is applicable to linear elements and bilateral elements only. Okay, so with this, I hope that now you are able to state Ohm's law and describe the conditions where it is not applicable. Now we will try to solve a simple problem. As already mentioned, V is equal to I into R. So if I take a simple, you take it as a, okay, let me take it as a, we are now confining only ourselves to DC networks. So this is some voltage V and this is a current I flowing in the circuit and this is the resistance R, right? So the relation between them is proportional to V is equal to IR, right? Or I is equal to V by R, or R is equal to V by I. We are now confining only to a simple circuit where I do have only one battery or a source and the other one is a resistor, right? And what is P? P is equal to voltage into I. P is nothing but power, right? Power is equal to voltage into I, or voltage into I. Again I can write it as V by R. So what I can write it as V square by R. Or if I replace V with IR, or it can be also written as I square into R. So any of these can be used for determining the power. Now what is energy? Energy is equal to power into time, right? So V into I into time, or V square by R into time, or I square R into time. The choice is yes, any of the equations you can write. Okay, so now we will try to solve some problems on this one. The first one, see, a small light bulb is connected to a 6 volts battery and draws 2 amperes of current. What is the net resistance of a bulb? So, which means that there is a 6 volts battery and to this one there is a bulb connected. Which means that this is a 6 volts battery and it is drawing 2 amperes of current. So what is the net resistance of the bulb? The concept is very simple. There is only one simple element. So V is equal to I into R. So what is R? V by I. What is the voltage in the entire? There is only one element, right? So it is 6 by the current is 2. It is 3. And the units of resistance is 3 ohms. Okay. Now, what is the power which is dissipated? P is equal to V into I, right? So it is 6 into, what is the current flowing? 2. How much it is? 12 watts. And what is the energy? For energy, I do need V into I into P, right? So V is 6, 2 is current. Time I have not mentioned, I will take it as time is equal to 2 seconds. So 6 into 2 into 2. 12 to the 24 seconds. Okay. So now, based upon this, let's take one more problem now. Determine the amount of current going through a 50 ohms resistor with a voltage of 120. So it is also a simple circuit. There is a resistor of 50 ohms and it is having a voltage drop of 120 volts. So what is the current which is flowing now? I is equal to V by R, right? So 120 by 50. How much it is? 2.4 amperes. If I want to know the power which is dissipated, power is equal to V into I. What is V? 120. What is I? 2.4. So what is this one? 288 watts. Okay. And see, there is one more problem here. In the following circuit, find the current I. Determine the power dissipated in the resistor. Now see here, this is a current will be flowing in this direction, right? Because it is the positive terminal. So current will be flowing in this direction. So what is, only one element is present here. This is just a meter here. So V is equal to 120, R is equal to 100. So 120 is equal to current into 100. What is I then? 120 by 100, it is 1.2 amperes. This is your current. But he is asking in milliamperes, right? So if I convert it into milliamperes, it is 1200 milliamperes. This is what I have mentioned here. So what is the power dissipated in the resistor? He has asked us to determine the power dissipated in the resistor also. E is equal to I square into R. What is I? 1.2 into 100. So its value is 144 watts. Okay. So I hope that now you are able to state the Ohm's law, and also I hope that you are now able to compute current, voltage and power in simple electric circuits. You try to solve these problems at your home, and we will try to solve them in the class also. In the next class, we will see about Kirchhoff's laws. There are two laws, Kirchhoff's current law and also Kirchhoff's voltage law. We will discuss about them in the next lecture. Thank you.